Hello everyone, welcome back to Advent of Code 2020. We're going to be doing day 7 today in Haskell, as always. Let's get started. Handy haversacks. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules are being enforced about bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags, alright? Apparently, nobody responsible for these regulations considered how long they would take to enforce. For example, consider the following rules. Light red bags contain 1 bright white bag, 2 muted yellow bags. Okay. So just a comma separating each requirement and a period at the end. Yeah, this very much seems like a text processing kind of day, or year. Okay, and I assume there's going to be something that tells me about bright white bags. Yes, they have a shiny gold bag. There's a shiny gold bag here, so we're building like a tree of stuff, I guess. These rules specify the required, okay. You have a single shiny gold bag, which I guess is going to be the root of our thing. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? Okay. Well, this is a bit more like it's not a humongously difficult problem, but it's more exciting than the last couple days, which were pretty simple. We want to build a tree here, and that's always a thing that's interesting to do in Haskell, where you don't have the order of the tree ahead of time, and it's like, oh, it's really how do you build a tree if you can't mutate it and you don't get the nodes in order? It's really hard to put them in the right order, right? And it turns out there are some cool tricks to do that, which I've used in previous years. Now, first of all, do we need, like, just to answer this question, how many colors can eventually contain a shiny gold bag? We don't even really need much of a tree. We just need I mean, I don't know. I guess it's still sort of a tree, right? We just don't need the labels on the edges. It would be interesting to graph this tree and see just how wacky it looks. But okay, anyway, let's get started. And just out of curiosity, in our input, it's many, many lines. 594 different kinds of bags. So this kind of reminds me of something in I think 2015, the first year. I still remember, I think it was problem 15, because I hated that problem. That was the one that I didn't do part 2 that year until much later. Because I felt that the way you were expected to solve the problem required information not present in the solution. It just happened to work if you try it. Not present in the problem statement. And it just happened to work if you tried it. But why would you try it when it's not guaranteed to work? And it just happened to work for every puzzle input you were given. Anyway, the reason it reminds me of that is just because you were building a tree again, and it was a very I remember it being a very deep tree. Or I think this isn't a tree, right? It's a graph. Well, no, it must be acyclic, right? But it doesn't have just one parent. Yeah, so it's a directed acyclic graph. This is like a Git repository, right? So what exactly is the structure of our data? This is something to think about. I think we have basically a rose tree, right? Where every node contains a label and a link to 0 or more children. And I remember I always, like, when I build these, I end up, like, you end up wanting them in reverse, right? Kind of. Because we're saying, okay, I have a label from a, for example, at the beginning, I have an example from muted lavender to dull brown, and so on. But and that's fine. Like, eventually, I could, for example, I could build the entire tree, and then for each type of bag, navigate down the tree to just explore it breadth first or depth first or whatever, and see if I eventually encounter golden or whatever it is that I'm supposed to have. Shiny golden, maybe? Shiny gold, yeah. But the problem is, this is, I'm certain, going to be a tree where a ton of that work will be duplicated. Because, like, when you explore muted lavender, you'll explore dull brown. And it's like, oh, okay, well, when we're exploring dull brown, we're going to explore dull brown again later, and it would, like, be wasted work. Now, what you really want to do is go the other way. Just start at shiny gold and traverse upwards from it, right? And it's kind of, like, weird, because if you imagine taking a tree and inverting it, or not a tree, this is a directed acyclic graph, but it is well, actually, I was going to say the difference is it's not rooted if you invert it. Imagine taking a tree and you invert it. You went from having one root and many leaves to many leaves and one root. But actually, there's no root, or many roots and one leaf. Anyway, but there's actually no root in this entire thing to begin with, right? So viewing it in reverse is really no different from viewing it normally, right? And so if we started with things that can contain gold, and then explored upward, we would still, like, run into a bunch of duplication, because I would say, oh, okay, I'm looking at golden bags, and I find, they can, let's see, shiny gold, for example, right? I would say, oh, those can be inside pale magenta bags. And then I would say, oh, and they can also be inside of dull white bags. And then I would go, let's say, exploring dull whites, and maybe it leads me back to pale magenta. So there's duplication there, so you want to be careful traversing the tree no matter which direction you're going in. I kind of feel like I don't even really want a tree. I just want, because there is no tree here, right? The shiny gold bags are kind of a root, but that's not actually all that useful. I want to build a graph, right? And traverse it in that way. Okay, so that's kind of nice, because if we're not building the data structure, like, never mind. Oh, whoops, wrong. Okay, anyway, let's get going on the inputs here, and we're going to need, obviously, like, some more complicated structures than we did last time. Data map strict as M. So we're going to be representing the graph as a map from key to the data at that key, i.e. the edge, the list of all the edges that it has. And we will probably need another map at some point, or maybe just a set. We'll need a set, I suppose, for all, like, tracking our visited nodes. So let's do that too. Import qualified data set as S. And we're gonna need import text regex applicative to parse this whole thing. What are you mad about? Is it because I... Yes? I broke it somehow? Did I... Looks right. Stack build? Do I have to get it to fetch dependencies or something? It looks fine. Okay. Why? All right, let's close Emacs. I don't know what's wrong. So I know we've done exactly the same thing in previous days and everything was fine. Now it's fine. Just some weird stale state, I guess. Okay. So we might as well. What is the type of our graph node, right? Data edge is something we want, I guess. Is it's an edge from bag. Well, we're not going to store the from node here, I don't think. That'll be in the map. That'll be the map key. And so it'll just be an edge describing a color and an int, which is how many. Yeah, it tells you how many of some other bag must be present. And we'll define a color to be a color of 2 strings, basically. I feel like one of these days I should stop using string. I should grow up and use text, but I don't know. I don't ever really want to do that. And I'm sure I'm like text regex applicative. Well, actually, I don't know how to make it work on text, but I assume it can. It would be quite a glaring omission if it couldn't. But okay, anyway. So we have a color and an edge, and our input is probably a list of, a data rule, let's say, is a rule from color to edge to list of edge, right? You say, here's what must be contained within some color, and there's a list of many things. And so I think our input is a list of rule. Okay. And so we need a parse function that turns the input into a list. Well, actually, honestly, our input might very well maybe should be the graph type, right? Because we're gonna need a graph anyway. Okay. So type graph map from color to rule. And our input then is just a graph. Garf. Something like this. And now we just need to parse out a graph from the input. So that would be something like m.fromList composed with map make entry composed with. Oh, I was thinking maybe I should. No, never mind. I was thinking if there's going to be more problems that are about like about processing text with double new line separated, I should make like a tiny library for handling those. And I got a little confused here about where exactly am I bailing out if this fails to parse, right? My input is a graph. I can just turn like the empty graph or something if it fails to parse. So make entry. Well, cat maybes, I guess. I don't know. Throw out all the... No, I want to know if a rule fails to parse. From maybe nothing. And let's import... traverse parse lines where, okay, so this I think is making some sense, where make entry of, and so I'm going to parse these to, I think, a rule. Wait. A color already has, sorry, a rule already has a color in it. This should just be a list of edge. The rule is actually only used for reading the input, and then later, when I put it into the map, I just need to know the list of edges, right? So make entry is a function from rule to color edge. Oh, this is kind of stupid, isn't it? Maybe I don't need this rule type at all. And parse is a function from, let's just make sure this type checks, and then I can write parse. String to color edge. Maybe of color edge, maybe. Oh, indeed, colors are not ordered. Good point. And eq, you're right. Okay, to be ordered, it has to be equable. Sure. All right, so that looks fine. This type is all right. And now we can do actually, let's put this in another where under parse, so it like doesn't, I don't know, there aren't any other top level bindings for prepare to have, but in principle it should not know about the regex parse uses. So we might as well just make it a sub where clause that only has a narrower scope. Rule is what? Let me go look at our input real quick. So it's a color of, oh, you know what? Rule is actually, we're probably going to want a do here, right? Just so I don't get lost in some operator soup again. So descriptor comes from word, let's say, and then we'll define word in a minute. And so to match lavender, what are we going to call that? Base is also a word, but we need a space here. And I'm using a bunch of stuff that I haven't defined yet. We're going to define it in a minute. String bags contain space. And then we have to take in a list of descriptors of things they have, right? And so we write contents I guess I can just write many of bag, numbered bag, numbered. I can actually write numbered bag and define what that means. But actually, there's some like reusable stuff that should be here. Descriptor space base I'm reusing here. So really what I want is like outer should be from a bag, which should be this. And then we have numbered bag. Yeah, that seems... Oh, many numbered bags, sorry. And after each numbered bag, we will be ignoring either comma space or a period. Okay, now I've kind of written like what I wish I could. Oh, right, I have to say pure of now bag is a color here. Bag contents, I get. Oh, outer comma contents is the idea. And all this stuff doesn't exist yet, which is fine. So let's put some types on, because I'm gonna get a little bit lost if I don't. And that's what types are for. So rule is a regex from of char returning a pair of color edge, right? Rule equals do this. Oh, and it's indented wrong. There we go. And okay, so it's just saying, I don't know if this is type correct. You're using a bunch of shit that doesn't exist, and that's very reasonable. Let's next define. Am I really only using the space in that one place? Bags contain. I'll use it more in the subcombinators, I guess. So a bag is basically this, right? Is that right? It's a word and then a word and then... Ah, no, I want to include the word bag in it because I'm using bag in these other combinators as well. So I should actually just parse like that, maybe? Muted lavender bags. I gotta tell you, I'm not like super in love with the regex library today. Seems like it might be easier to write this by just like some combination of splits and regular regex stuff in another language, but I don't know. We'll see. This is a complicated enough input, I feel like, that it's kind of nice to have it more spread out and clearly labeled than a typical PCRE regex, but I guess we'll see. So, and then we parse another space and then the word bag, right? Yeah, we want like bag contain. Okay, got it. And we say pure of. Oh, what does bag return? It's an re of char to color? Yeah. Color of descriptor base. Simple enough, right? Space and word aren't defined, that's fine. Honestly, space is just char of space, like it's not really helping much, right? I kind of like it though, because what if I decide to like handle? Yeah, we'll just make a quick little thing for that as well. Space is sim that. There you go. Word equals many. I guess just psim of not equal space. Okay, and all we have left is numbered, which is a regex a function that takes a regex as input and gives you back another regex. Isn't that exciting? I guess I'll put it here where the interesting ones are, before space and word, which are boring. Numbered is a function from re char a to re char of. And so what's an edge? Basically, it's I was gonna make it parametric here. Which is like, I mean, the kind of nice type that I think this should have is a char of a and int, basically. And that's fine. It's just like I'm gonna have to wrap it in the edge type in a minute, which is, you know, whatever. I guess it's fine. We'll just write we'll wrap it up in an edge here. Edge, no. Uncurry edge. Yeah, that's still type. Well, okay, we actually don't know if it type checks here. Numbered equals undefined. Let's see. Does that make sense? Not quite, huh? Oh, this should be string bag. Oh, of course you don't need parents here. That makes sense. What are you mad about many being there? You don't like the $sign? Oh, that's certainly true. Yeah, sure. I could get rid of the parents here, and now you need the. Oh, yeah. You certainly don't need the $sign if you're wrapping this like so. Okay. So this all type checks. It certainly seems like a lot of words for a fairly simple input, but well, you know, here we are. So this is pretty simple, I think. It's just do, and we num is read of many psim is digit, which we'll go get from data char. And then we'll read the t, or x, I don't know, from numbered of, excuse me, p. We'll just read the regex we were given, and then if num, I can't do an if here based on num because I'm not allowed to make decisions based on what I saw previously. So we'll just optionally consume an s. How do you... I could just consume many S, I guess. That's sort of cheating, but sure. I'm sure there's something in Haskell called like optional. Like I don't know. We'll look it up, right? Tell me, Google. What is the function I'm searching for? I have an alternative f, and I have an f, but I want. Sorry, I have an f a, and I want an f of maybe a. Is that at all what I'm thinking of? Maybe my types are completely bonkers here. No, it's just called optional. Yeah, perfect. So we could say optional s. Okay, that's probably better, right? And I have to import this, I suppose? No, it just has a different type, which is fine. And then we'll say pure of x num. There you go. So, oh, I'm sorry, here we are, we're back. I just wrote basically this. Nothing much happened here. So, I would like to test this now. And, oh, I guess I want edge and color to derive show. I know that's spelled wrong. I'll be with you in a minute. And I would like to prepare of, let's say, the first 2 lines of my input. It did not parse. Fair. You know what? I feel a little silly now because these combinators, some of them might be useful externally to test, right? But good news is, since I gave them types already, I can just like lift them up to the top level and see where things went wrong. And we're gonna have to unindent this a fair bit here. And it's mad that I didn't put types on these, but that's fair. I don't really care. So let's do some testing, shall we? Muted yellow, let's say, and I just want to parse that with. Do I actually have a color? I don't. Oh, you know what? I just realized. No, that's fine. Let's just parse that. Yeah, it's a color that's muted and yellow. That makes sense. So bag looks fine. And therefore space and word are probably fine as well. How about a numbered bag? What if we said 10 muted yellow bags? That doesn't parse. Oh, did I forget to write many? No, I didn't. Oh, I just forgot the space. Space. There you go. Yeah, there you go. It's 10 muted yellow things. All right. So if I ran this again, now it does parse. We get a single color rule for muted lavender bags. It can contain 5 dull brown bags, etc., etc. And then we get one more for plaid aqua bags. Oh, you know what would have been a better word? than descriptor would be like adjective, but I guess they're pretty similar words, all things considered. All right, so I'm going to just put these back where I think they really do belong, which was here. Now, when I hit tab, it's not actually going to indent this, is it? Oh, man. The worst. So we want to indent by 12. It's a little bit silly, but... All right, welcome back. Sorry about the interruption there. I was trying to indent this stuff, and the key binding that I was using in Emacs to do that overlaps with the key binding I have in my recording software to start or stop recording. It doesn't come up that often. When do you ever hit Control-1, right? But I was doing it here. So I got that all indented. The parsing is still fine. And I was working on part 1, which the idea is to find, rather than trying to traverse the graph in the order it was given to us, I wanted to traverse it in the other order, starting from a single node, walking upwards. So I wanted to first reverse the direction of all the arrows. That's what this contained in function does. Well, it's not a function, it's a value that I build. So we take in a graph, and then I build up a different map that's the order I actually wanted it, where we have a map from colors to a set of colors that can contain them. m.fromListWidth takes a combining function and then a list of entries, and it combines them. Anytime there's an overlap, anytime you have the same key twice, it combines the value using the combine function. And here we're just using monoids, mappend here, monoid, I'm sorry, monoid, goodness. We walk over the key value pairs in the original map, and for each rule, we then look at each bag in the each bag that can be contained, and then we say, okay, that bag that could be contained, here's one thing that can contain it, and we count on from list width to mappend the results together for us. And we're going to do a stateful function, where we just walk we start at a root and we explore all of the nodes available from that root. And just put them in our set of things that have been visited. And exec state is going to give us back the state that still exists when we're done with that. So walk of, oh right, I'm not done writing the type. Color to state is not a type that makes any sense. So our state is a set of color, and our value is actually like nothing. We don't care about the value. Walk of C equals probably do. We're going to let parents equal. I'm sure that I can simplify this, and I will once I'm done writing it, but I just want to do stuff in order and then write it in a pretty order later. Let parents equal where's my contained in C? Is that right? Yeah. So this is cheating. Like, it's really, this lookup in principle could fail, and this type, it has an exclamation point to warn you that it's a dangerous function to call. If you call it on a function that, on a key that doesn't exist in the map, your program just explodes. But we know that there won't be any such things because we built it this way. I think. Actually, yeah, this is a little dangerous, isn't it? because there'll, I assume, be some outermost thing that is not contained in anything and therefore won't be in our map. So what I actually want is m.lookup with default. Does that exist? Is that a real thing? Where's my browser window? I'm lost. Here it is. Haskell data map. Data map strict. Default. Find with default. There we go. And it takes the default value, which for us is just s empty, saying can't be contained by anything. And then it wants a key and then a map. Fine. C contained in. This at least should type check. Right? Yes. No, yeah, we want contained in. That's our, yeah, that state is not changing. And then for each of these parents, we're going to walk. No, I should be more careful. Scene asks, or is it called gets? I wrote gets, but I think I want asks. No, asks is in reader, gets is in state. Gets m dot member takes the key first. So I guess I want, it takes, yeah, I want it something like this. No, it wants the key first, and that's what I have. m.member of C. And then we will guard not seen. We have to import so if we get to a node and we've already seen it, we'll stop. And then we will modify with m dot insert wait, no, not m dot insert. We have a set. Oh, s dot member. Thank you. I just want s dot insert of C. And then finally, we will traverse walk over parents. Is traverse with an underscore? Does that not exist? I know mapm underscore exists. Haskell, I mean, I have Hoogle open, right? Yeah, you just have to import it from foldable. Okay. A little surprising. Import data foldable diverse. Okay. So this seems reasonable, right? It's gonna be like friggin' impossible to debug if I'm wrong. And that's a, oh my gosh. What are you upset about here? Oh, I didn't, I should put the root here, thank you. Okay. But it's still wrong. So exec states type, oh, it wants, It actually takes things in the other order? That's such a weird order. Okay, I'll flip it then. Really? What's wrong with guard here? Notice this for monad plus on identity, which is, I guess, fine. But shouldn't there be one for state? I guess not. Okay, fine. We'll use when instead. When not seen, do. And we'll just put all this under here. Oh, unless? Okay, I didn't know that existed. Now it actually type checks, which is exciting. And it should give us back... Well, you know what? We could put the modify up top, and then just inline parents. This seems fine. So it'll give us back. You know, actually, let's run this function on a simple input and make sure it looks right. We had a thing in our. We had this value, right? We had this prepare, and if I wrote reachable from takes a color and then a graph. Color, let's say, how do you get to drab orange? With this map. And it says, of course, it's contained inside a muted lavender. So it actually looks right, which is good because I was going to have a lot of trouble debugging if it was wrong. That's something I'm definitely not experienced with. Not very good at in Haskell yet. Okay. Oh, hang on. It actually says you can get to it from drab orange and muted lavender? Oh, of course, right. That's a thing I was planning to fix in part 1. Is that, of course, you can trivially get to drab orange from drab orange by, like, not going anywhere. And so I believe our puzzle input wants us to not do that, right? Yes. It does not want us to include the shiny gold bag itself, which is quite reasonable. So we will just remove that. The number of bag colors can eventually contain at least one. So we want an int. Part 1 is length of s dot delete gold of reachable from gold. And I think that's all. And we'll define gold here because we're using it a few times. Gold as a color. Actually, let's call it gold is fine, whatever. Gold equals color of shiny gold. This all type checks. I mean, how wrong could it be? Stack run. 0. It's impossible. Can't be done. Okay, well, that's sort of a problem, huh? How is it that it worked with the original input? Okay, first let's just have part 1 be length and make sure we got all the rules. we didn't fail to parse them somehow. Because maybe, yeah, we didn't. Okay. So there was, we tested our parser on like one very small input. And it worked, and we were like, okay, it's probably fine. Because that small input contained, it seemed like, all of the interesting features, right? We have two different rules separated by a new line. It works even with the trailing new line, although I don't think there would be one. Oh yeah, of course there is. But it gets eaten up by lines. And also, somewhat importantly, it has a 1, right? Saying that we got our like handling of the optional s at the end correct. So is there anything weird going on in our input, maybe? Every color has like exactly 2 words, which is fine. It's a little bit hard to figure out how to debug that. I wish they'd given me this problem on Saturday instead of Sunday. I do have to go to work in the morning, in so much as anyone ever leaves their home if they work in software. So, like, how do you even debug this at all? I guess you could do like you could try to bisect to figure out which line is the problem. Oh, here's a question. Let's ask whether each line parses. And if there are any lines that don't parse, that's an interesting one to look at, right? So let's say instead main equals read file of input.txt. Oh, sadly, prepare already has this all built in, huh? Okay, let's put parse at the top level. Since it's apparently broken. Oh, paste. I want to delete this rectangle. I keep getting it wrong. Let's start here to here. There you go. You can actually get Emacs to it doesn't matter. Okay, so now we can write let's just say do oops, input read file input.txt, and then for lines input do if parse of line is case parse line of nothing put stir line of line. Okay, we have to import this from who knows where it lives. Data foldable, apparently. You're right, I don't need to do, but I thought I might have, so I'm leaving it there. And if we now run stack run, of course it makes sense there would be bags that contain no other bags. Okay, well that's an easy fix. We just need numbered to be let's see, we have contain already, yeah. Yeah, so numbered needs to be empty or do. And we'll just define empty. Empty is an re char to Am I putting this in the right place? I guess so. It needs to be actually, though, empty of p. Empty is very simple, though. Wait, am I still stupid? What is wrong with our input again? So we have that's why I'm confused. It should not be, it doesn't go here in numbered. It goes at the top level, kind of, in rule. Empty of, yeah. Okay, I see. So maybe what I'll do is the following. And then say it's either empty or full. Contents takes in empty or full. Where, and we'll put this one inside of rule, I guess. Full is this. Oh, I don't need to do it all. Or a name. And empty equals string of no other bags, which we ignore and say pure nothing. Oh yeah, you're right. I can there's a function for this, right? No. Oh, I want it has to put in the other order. Whatever, I don't care. Shadowing is fine. So if I now write If I run it again, they all parse. Okay. Why did I delete my old main? What a fool. I meant to just like, I don't know, uncomment it or something. Okay, and if I run this, we get 248. Now this is, I believe, still using an old part 1 that I was using for test. No, this is correct. We found 248 were reachable. Okay. Let's enter 248. That is the number I got, right? Yeah. That's the right answer. Whew. I was nervous there. Let's get this committed. Oh, I didn't commit day 6. I have changes to day 6? Ah, I thought it would be nice to take this this repeated thing and list it out from part 1 and part 2. Okay, well we can do that in a minute. So we added transformers. Actually, I want to get the parsing fixed first. Oh, okay, yeah. So we'll just call this commit fix parsing, I guess. Hello? Give me back my. There we go. Really? I thought. Yeah. Wait, I'm so confused. We deleted part 1 and like. Oh, this is 2 different chunks. I see. So we will not add this chunk or this one. We will add this. Day 7. Parse empty bags correctly. And there was one diff. Oh, whoops, we're looking at day 2. One diff that I wanted to throw out, which was this extra line. There we go. We'll call this day 6 refactor common function. I don't know, whatever. We'll put that in front of our day 7 changes. And I guess we actually just want all this now. Yeah, git commit dash m day 7 part 1. And let's reorder all these changes here. We put this up here. And I think I will keep this commit different because it's sort of useful, right? No, I don't know. Let's just roll it in there. There you go. No one ever needs to know I made a mistake. Okay, back to part 2. It's getting pretty expensive to fly these days, not because ticket prices, because of the ridiculous number of bags you need to buy. Yeah, your shiny gold bag, So the single shiny gold bag must contain 1 dark olive bag, and the 7 bags within it. Yeah. All the bags, even if it becomes topologically impractical. Well, that's fine, because we can just memoize a function that's like how heavy is this bag, which is like what's contained within it. This should be acyclic, right? Yeah, this is sort of what you would have expected them to ask, and they did ask it, so that's fine. So we don't need reachable from at all. But we're going to do a very simple kind of thing. We're going to do a function similar to walk, I think. And we'll write wait of takes. Again, we could just inline gold into all of these things. But I like for part 1 and part 2 to be the only things that are like specific to the question being asked, and for the functions to be generically operating on the data structures that we have. Weight of takes a color and a graph and returns an int, and I think that's all, right? Actually, it would kind of be nice if this were our stateful function. Here we need our state to be a map, not a set. And I don't really need... Okay, well, we'll make this return an int, and it'll have an inner function that does the walking. Weight of CG equals we want to look up our color in flip exec state empty of I mean, wait a minute. I actually kind of do want... I think I can just run state, actually, instead, and it comes out looking a little nicer. Yeah, it will. Because we can work... We can actually keep the weights in the value of our monad, of our stateful computation, and not have this weird lookup that kind of sucks. We'll just run state. What is the type of run state, by the way? It won't tell me. Okay, how about now? No? What is the type of run state, you jerk? Run state. Takes, yeah, state. Okay, we still have to flip it. Oh, no, I want eval state. Run state gives me more than I need. I forgot. Run state gives you both the state and the value, but I just need the value. Okay, and this actually type checks, although it's obviously not going to work because undefined doesn't do anything. Of do. Our actually, let's put the eval state empty in part 2, and then this can just statefully, given an m map from color to int, give you an int. Yeah, and then weight of is the recursive function. Okay, is flip eval state empty of weight of gold. Does that make sense? Is that correct? What, probable cause weight of is applied to too few composed with weight of gold. There you go. So now we can say do. So we have a color that we're trying to look up. And what we just need to do is look up, yeah, we can just, actually we don't even need to do because we just have an if to begin with. If, no, I do need to do because I have to read what's currently there. Present, I guess, gets m.member of C. I don't know, I want to like look it up, and if it's not there, then like case match on whether it was there or something. I don't know, I guess this is fine. Case present of nothing, then we have to actually compute it. Okay, we'll put the just first, right? Just W, we'll just say pure W, nothing. Then we need to do some more computation to figure it out. I have my graph, which tells me what can, yeah, okay. So if there's nothing here, I want to let contents be G of C. And that will be a list of edges. Then I want to do a stateful computation on each of those edges and combine the results into a list with traverse, and then sum them with yeah, okay, so fmap sum, well, let's just sum over traverse weight of, using the same graph. No, I have to write a more traverse way, let's say, over contents. Where exactly do I want to put way? Could go in a number of places, right? It could go in case present, but I don't think I need that. Yeah, we'll put it at the top level of weight of, where way is a function from edge to state. Oh yeah, mmap color int. I don't have that type already. Okay, mmap color int and int. Yes. Okay. Way of edge C num equals. Yeah, and that's just num times the result of weighing C, right? No, not weigh, weight of, because I need it to be like that. Oh, yeah, and I need to look up the right map function for lookup. There's a function called lookup. C is shadowing the outer C, which I agree is a little confusing, but that's all right. So we can easily inline this contents thing, that's fine. And then we don't need to do. Ah, I do need a do, because I need to actually cache the result. Modify m.insert takes a key and then a value, so we'll give it C weight. Like that? Yes, we weren't doing any caching previously. Okay, I don't know. Is this gonna work? It'll be exciting. I don't know. Let's just try running it. What's the worst that could happen? Zero. Well, it didn't work. Did I... That's true. We never add anything. We just multiply a bunch of numbers together. Now, there's no ones in here. There needs to be a 1, not a 0. At some point. And so I think we want to like add 1 to the weight of this. Yes. The weight of a bag that contains foo is 1 plus foo. So 1 more than the sum of that. Oh, I want that princess there. I know I don't need it, but oops. But I'm more comfortable with it there. Sometimes I remember that it's not necessary, but sometimes I don't. All right, that's a large number. Seems plausible. Let's give it a try. Too high. Okay. You got me. It was wrong. Let's try their simple input. They give you those for a reason. So we'll grab this. And see what we get from that. Probably it's wrong. Does not exist. Oh, I put it in the wrong directory. Let's kill this one. That file doesn't exist anymore. 127. Ah. Oh, of course. The result that we're supposed to get is 126 because I counted the weight of the gold bag, but that's not what they asked me. They asked me how many bags are inside of it, which is going to be 1 less than its weight. So I think we can just subtract 1 and be good here. So let's put back our ordinary input here. And part 2 is just pred of that. I could do it differently, I guess, and say change weight of to like bags contained by, and instead of putting the +1, where did I even put it? Here. I don't know. I would have to structure things a little differently, I guess. So if I run it now, I should get exactly one less than I did before. But like, let's check. Yeah, 57,281. That's the right answer. Okay, thank goodness. We're finally done here. It was a longer one for sure. Anytime you have to mess with a tree, I feel like things get a bit out of hand. So let's remove our test input here and put together a meaningful patch set, which I guess is just part 2, right? Day 7, part 2. Yeah, I mean, weight of is not that bad. And it didn't really take that long to write either. But it wasn't totally trivial. You guys can't see this. I'll never get the hang of like managing 2 screens. It's just like you're used to switching between windows so quickly, and I have the preview window up, which is how I can tell I've made a mistake, but I'm not usually paying much attention to it. Yeah, so we just wrote this, which is fine. There's maybe something to be said for like extracting out a function where you like have a stateful computation and you want to memoize it somehow, but I don't know. Seems a little hard. I'm not going to. I guess we could resolve the issue with C shadowing by calling this one root, but it doesn't matter. I think we're just done for today. So that's all. Thanks for watching, and I'll see you next time.